Surface areas and volumes.
Area. The magnitude of a plane region is called as area. Volume. The magnitude of a space region is called its volume. The lateral surface area of a solid. The sum of area of vertical faces of a solid is called as lateral surface area of a solid, also called as vertical surface area. Curved surface area of a solid. The area of curved surface of the solid. Total surface area. Total surface area is the sum of the areas of all its faces like base,
lateral surface, curved surface.
Example. In the given figure, a toy made from a hemisphere, a cylinder and a cone is shown. Find the total area of the toy. Given, for hemisphere, radius is equal to r is equal to 3 cm. For cylinder, radius is equal to r is equal to 3 cm. Height is equal to h is equal to 40 cm. For cone, radius is equal to r is equal to 3 cm. Height is equal to h is equal to 4 cm. To find total surface area of a toy. Solution. Here, radii of a hemisphere, a cylinder and a cone are equal. For cone slant height L. Here, curved surface area of a cone is equal to pi rl, where slant height L is equal to root of r square plus h square. Therefore, L is equal to root of 3 square plus 4 square. 3 square becomes 9 and 4 square becomes 16. Therefore, L is equal to root of 25. Therefore, L is equal to 5 cm. Total surface area of a toy is equal to curved surface area of a hemisphere plus curved surface area of a cylinder plus curved surface area of a cone. But curved surface area of a hemisphere is equal to 2 pi r square. Curved surface area of a cylinder is equal to 2 pi r h. Curved surface area of a cone is equal to pi r l. Therefore, 2 pi r square plus 2 pi r h plus pi r l, which is equal to pi r into 2r plus 2h plus l, is equal to pi into 3, 2 into 3 plus 2 into 40 plus 5. Here, 2 into 3 becomes 6 and 2 into 40 becomes 80, which will become pi into 3 into 91, implies 273 pi square centimeter. Therefore, total surface area of a toy is 273 pi square centimeter. Example. Observe the measures of pots in adjoining figure A and B. How many jugs of water can the cylindrical pot hold? Given. For conical water jug, radius is equal to r is equal to 3.5 cm. Height is equal to h is equal to 10 cm. For cylindrical water pot, radius is equal to r is equal to 7 cm. Height is equal to h is equal to 10 cm. To find number of jugs of water the cylindrical pot can hold Bn. Solution. Let the cylindrical pot hold n number of conical water jugs. Therefore, n into volume of conical jug is equal to volume of cylindrical pot. Therefore, n is equal to volume of cylindrical pot upon volume of conical jug. But volume of a cone is equal to 1 by 3 pi r square h, and volume of a cylinder is equal to pi r square h. Therefore, pi r square h upon 1 by 3 pi r square h, here 3 goes to the numerator and pi cancels out, which is equal to 3 into 7 square into 10 upon 3.5 square into 10. Here 10 cancels out, which implies 3 into 7 upon 35 by 10 square. By simplifying this, answer is 12 jugs. Therefore, the cylindrical pot can hold 12 jugs of water. Try some more problems for practice.
Volume of a combination of solids. Example: a juice seller was serving his customers using glasses as shown in figure. The inner diameter of the cylindrical glass was 5 centimeters, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. If the height of a glass was 10 centimeters, find the apparent capacity of the glass and its actual capacity. Use pi equals to 3.14. Solution. Since the inner diameter of the glass equals 5 centimeters and height equals 10 centimeters, the apparent capacity of the glass equals to pi r square h equals to 3.14 into 2.5 into 2.5 into 10 equals to 196.25 centimeters cube. But the actual capacity of the glass is less by the volume of the hemisphere at the base of the glass, that is, it is less by 2 by 3 pi r cube equals to 32.71 centimeters cube. So, the actual capacity of the glass equals to apparent capacity of glass minus volume of the hemisphere equals to 196.25 minus 32.71 equals to 163.54 centimeters cube. Example: a solid toy is in the form of a hemisphere surmounted by a right circular cone. The height of the cone is 2 centimeters and the diameter of the base is 4 centimeters. Determine the volume of the toy. If a right circular cylinder circumscribes the toy, find the difference of the volumes of the cylinder and the toy. Take pi equals to 3.14. Solution. Let BPC be the hemisphere and ABC be the cone standing on the base of the hemisphere. The radius BO of the hemisphere, as well as of the cone, equals to 1 by 2 into 4 centimeters equals 2 centimeters. So, volume of the toy equals to 2 by 3 pi r cube plus 1 by 3 pi r square h equals to 2 by 3 into 3.14 into 2 cube plus 1 by 3 into 3.14 into 2 square into 2 equals to 25.12 centimeters. Now, let the right circular cylinder EFGH circumscribe the given solid. The radius of the base of the right circular cylinder equals to HP equals to BO equals to 2 centimeters, and its height as EH equals to AO plus OP equals to 2 plus 2 equals to 4 centimeters. So, the volume required equals to volume of the right circular cylinder minus volume of the toy equals to 3.14 into 2 square into 4 minus 25.12 equals to 25.12 centimeter cube. Hence, the required difference of the two volumes equals to 25.12 centimeters cube. Try some more problems for practice. Conservation of solid from one shape to another.
What is volume? Volume is the amount of space occupied by solid, liquid or gas in three-dimensional space. Volume is also called a capacity of a solid. If the length, breadth and width of a solid is in units m, centimeter, etc., then its volume is given in units cubic m, cubic centimeter, etc. Surface area refers to the area of the 2D outer surface of the three-dimensional solid. In other words, surface area is the sum of all areas of each of the sides. There are two types of surface area. Lateral surface area. The lateral surface of an object is the area of all the sides of the object, excluding the area of its base and top. Total surface area. The total surface area of a solid is the sum of all the areas of all the faces or surfaces that enclose the solid.
Example: a cone of height 24 centimeters and radius of base 6 centimeters is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Solution. Volume of cone equals to 1 by 3 into pi into r square into h equals to 1 by 3 into 3.14 into r square into 24. Since the volume of clay in the form of the cone and the sphere remains the same, we have volume of sphere equals volume of cone equals to 4 by 3 pi into r cube equals to 1 by 3 into pi into r square into h into 4 by 3 into 3.14 into r cube. By further solving we get r equals to 6 centimeters. Therefore, the radius of the sphere is 6 centimeters. Example: a copper rod of diameter 1 centimeter and length 8 centimeters is drawn into a wire of length 18 meters of uniform thickness. Find the thickness of the wire. Solution: the volume of the rod equals to pi into 1 by 2 the whole square into 8 equals to 2 pi cm cube. The length of the new wire of the same volume equals to 18 meters equals to 1800 centimeters. If r is the radius in centimeter of cross section of the wire, its volume equals to pi into r square into 1800 centimeters cube. Therefore, pi into r square into 1800 equals to 2 pi. That is r square equals to 1 by 900, that is r equals to 1 by 30. So, the diameter of the cross section, that is the thickness of the wire, is 1 by 15 centimeters equals to 0.67 millimeters approx. Try some more problems for practice. Frustum of a cone.
As we just saw, a conical part, when cut horizontally in two parts, one part is frustum and the other is cone. Frustum. Here, R1 and R2 are radii of circular faces of frustum, where R1 is greater than R2. Slant height of frustum denoted by L is equal to root of h square plus R1 minus R2 square. H is equal to height of frustum. Curved surface area of the frustum is equal to pi into R1 plus R2 into L. Total surface area of a frustum is equal to pi L into R1 plus R2 plus pi R1 square plus pi R2 square. Volume of the frustum is equal to 1 by 3 pi h. R1 square plus R2 square plus R1 into R2. Example: the radii of ends of a frustum are 14 cm and 6 cm respectively, and its height is 6 cm. Find its 1. Curved surface area, 2. Total surface area, 3. Volume. Pi is equal to 3.14. Given R1 is equal to 14 cm, R2 is equal to 6 cm, h is equal to 6 cm. Solution: 1. Curved surface area. Curved surface area is equal to pi L into R1 plus R2, and L is equal to root of h square plus R1 minus R2 square. Therefore, slant height is equal to square root of h2 plus R1 minus R2 square. Square root of 6 square plus 14 minus 6 square, and 14 minus 6 square becomes 8 square. That is equal to square root of 36 plus 64, and 36 plus 64 is equal to 100. Therefore, L is equal to 10 cm. Curved surface area of a frustum is equal to pi L into R1 plus R2 is equal to 3.14 into 10 into 14 plus 6 is equal to 31.4 into 20 is equal to 628.0 square centimeter. Therefore, curved surface area is equal to 628 square centimeter. 2. Total surface area of frustum. Total surface area is equal to curved surface area plus pi into R1 square plus R2 square is equal to 628 plus 3.14 into 14 square plus 6 square, which is equal to 628 plus 3.14 into 196 plus 36. But 196 plus 36 is equal to 232, implies 628 plus 728.48, which is equal to 1356.48 square centimeter. Therefore, total surface area is equal to 1356.48 square centimeter. 3. Volume of a frustum. Volume of a frustum is equal to 1 by 3 pi h into R1 square plus R2 square plus R1 into R2 is equal to 1 by 3 into 3.14 into 6 into 14 square plus 6 square plus 14 into 6 is equal to 3.14 into 2 into 196 plus 36 plus 84. But 3.14 into 2 is 6.28 and 196 plus 36 plus 84 is equal to 316, which is equal to 1984.48 centimeter cube. Therefore, volume of a frustum is equal to 1984.48 centimeter cube.